Okay, we're looking at electricity bill here. So the motor over, so they start from the value at the top in January, and then it gets to this value then afterwards. So it's used the gap between the two. So we're going to take 27,065, and then we're going to take off 25,092. So 27,065 take away 25,092, sorry, 192. That then gives us 1,873 units used, and I'm going to times that then by 11.45 pence, which will then give us our value that we're looking for. Now that's in pence, so if we write out rounding to the nearest whole number and then we put our point in, it'll work out as £214.46. That's question 1. Question 2 is the travel sort of graph question. So we've got different parts to answer on here. So first bit, part A, is asking us how far is Cyan from her house at 9:30, so you go across, up at 9:30, go across, so she's 10 kilometres away. Part B, part 1, library's 20 kilometres away from Cyan's house, so it's up here. At what time did she arrive at the library? So she arrived at the library at 10. So 10 o'clock. Part 2, how long did she spend at the library? So she stood here for 10, 20, 30 minutes, so 30 minutes there. And then part C, at what time did Cyan arrive back at her house? So we go down here and it's this point here, so that's 20 minutes past 11, 11:20. Part D is, I would say, the tricky bit. What you're given is you're given part of the hint because the answer says kilometres per hour, so it means kilometres divided by hours. So the speed on her way back from the libraries is this journey here. So she's gone 20 kilometres, so the 20 kilometres isn't the problem. Then dividing by, well, it's 1, 2, 3, 4, 5 jumps, 50 minutes. Now if you wanted kilometres per minute, you just divide by 50, but it wants per hour, so you have to put your 50 minutes as a fraction of an hour. So my advice really there is to put your 20 and then divide it by, open a bracket, 50, and then divide it by 60 and close your bracket, and then that will give you the answer then of 24 kilometres per hour. Question 3, we've got a parallelogram. This is all about if you know the area of parallelogram rules and so on. So height is x. We've got the perimeter of the whole thing, so perimeter is equal to 44. The length of the parallelogram is 3 times as long, so the length is 3x. The slant height, this slant here, is 2 centimeters longer than the height. So we've got those values in. Find the area of the parallelogram. Well, to find the area, we need to do the length, or the base, times the height. So that's 3x times x, but we don't know what x is yet. But we have an interesting thing about the perimeter. So if we add up the sides of the perimeter, so that'd be 3x plus x plus 2, plus another 3x on top, plus another x plus 2 here. And that then equals 44. Where are x's? So 3x is 4x, 7x and 8x. 8x plus 4 equals 44. Take your 4 over. So 8x is 40. So then we divide by 8. X is then 5. So to then work out the area, it's going to be the length, which is 3 5s, which is 15. Times it then by the height, not the slanted height, the height, which is 5. And that will give you then 75 as your area, and it'll be centimetres squared, which is already written down in the question, the centimetres squared bit. Question 4. this one, we've got two parts to it, so it's actually hidden. The first bit is hidden behind. So I'll just change the size of that so we can see it. And then there's the second bit. So first thing we've got to do, in the exam you can ask for tracing paper. So my advice is first of all to do that. The rotation, what I imagine here is I imagine it's like a flagpole. So if you spun from that point as a flagpole, the flagpole, if it was 180 degrees, would go up here. So then your shape would be drawn in like so. That should be absolutely spot on there, sorry for the rough drawing. But then that is your label the triangle A as well, so put A in, and then that's 2 marks. Translate the triangle P by vector 6 minus 1. Now think of 6 minus 1 as a coordinate. It means you go 6 across and 1 down. So from the actual shape, you go 6 across, 1, 2, 3, 4, 5, 6, and 1 down. So take another point, 6 across, 1, 2, 3, 4, 5, 6, and 1 down. And then you draw your shape in. Sorry, again, awful drawing there. Use a ruler and a pencil, and then label that B. So there's 4 more marks for you. We then move on to 4C, which asks us to describe this transformation in a single transformation. Well, it's actually a reflection in the line. Now what line is it that we're looking for? If I just draw on the line that we actually are reflecting it in, it's this one here. What line is that? Well, that line is when, if we look at these points here, 1, 1, 2, 2, 3, 3, 4, 4, it's when x is the same value as y. So it's in the line y equals x. Question 5 requires some substitution. So what you've got is an equation where you're given, or you're trying to work out what the x value is. So I'll just make that a bit larger so you can see it. And you're told that it's between 3 and 4. So if you know it's between 3 and 4, the next obvious solution is to try x is equal to 3.5. In doing so, we put that in the calculator, so it'd be 3.5 cubed, and then add on 2 lots of 3.5. So that will then give us 49.875. Now that then is too low, so we may try x equals 3.8. So 3.8 cubed, and then we're going to add on 2 lots of 3.8, and that will then give us 62.472, and that's too high because we're looking for 60 as our answer. So we want to try just something slightly lower, 3.7. So 3.7 cubed plus 2 lots of 3.7 will then give you 58.053. Now that's too low. What you don't then do, which some students do, is say, well, this one here is a bit closer to 60 than this one, so I'll take 3.7. You have to do a trial to 2 decimal places. So if you do 3.75 cubed plus 2 lots of 3.75, that will then give you 60.234, and that's too high, and because that's too high it means it's going to be slightly lower than that, so then to 1 decimal place which you're working, x then has to equal 3.7. It's crucial that that last trial is put in.